Starting recording. Okay, cool. All right, so today I'm going to start talking about using GhGL for writing billboards. So we're going to do this kind of effect here. Billboards are basically screen-aligned quads that are textured and are pretty commonly used. I can see them being used quite a bit in the grasshopper context. Usually for placing images of people loitering on your building project. There's two different ways I want to cover how billboards are created with GhGL. There's a traditional vertex shader approach, which takes a bit of extra coding, but I think it's good to cover because this would be how you would also write billboards if you were writing GLSL for web development, because the second approach uses geometry shaders, which aren't available on WebGL. Okay, so let's just start with a brand new document, and excuse me, start with some points. Set a few points on the screen, and those points are going to be where I'm going to want to draw my billboards. Now in OpenGL, what we're going to need to do is take those points and we're going to need to convert them into triangles. So in this respect, we want to actually take those points and do something like this. We want to have a point that starts and turns into two triangles. And those two triangles we would then be able to draw a image on those triangles. And then the corners of those triangles would be something along the lines of you'd have corner 0 there, corner 1 here, 2 here, and 3 right here. So this is what we're gonna do. We're gonna take a point, and for traditional using a vertex shader, we're gonna take that point and I'm gonna duplicate it into several points, and then those points will get passed into GhGL and drawn as triangles. So the first step to do here, let's see, use my little cheat sheet over here of another computer, is I'm going to need 6 points. So it's going to be 1, 2, 3 for the first triangle, and then 4, 5, 6 for the second triangle. So I'm going to take those points, I'm going to duplicate them. And let's see, set this to 6. So now we have duplicated points coming out, but I want to pass those points all in. I want to do 6 of the same points over and over again, and then 6 other points over and over again. So the order, I change that order to false here for the duplicate data. So you just get the first point comes in as 6 of the same point, and then 6 of another same point, 6 of another same point. I'm also going to define that these triangle points. So let's see, that would be, change this to multi-line data, go 0, 1, 2 for the first triangle, and then 0, 2, 3 for the second triangle. And I'll feed those into some number component here, and I'm going to duplicate those also. So let's see, probably going to need, let's see, what do I do here for this one? I see. So I'm going to need to get to the number of points. And then this will come out as a panel also. This is all a lot of extra work just to get points to be fed into GhGL in some sorted order that represents triangles. So here we can see we have 0, 1, 2, 0, 2, 3, 0, 1, 2, 0, 2, 3. And this maps up with all the points that we're going to be passing in. So now we can actually start writing a shader. So I'm just going to use a regular GL shader. And for my vertices, I'm going to hook in those points. And then I'm going to change V color, and I'm going to rename that to index. And I will feed these indices in here. And then I'll go into my shader itself, start editing it. And it's, so the first item is still named vertex. The second item is now index. And instead of a vec4, these are just a list of numbers. So I want this to come in as a float. And so then for every single vertex that comes in, it's got a corresponding index. And then we don't want to change, we don't want to set a color because we don't have a color yet. And excuse me, allergies. Change the fragment color so it doesn't actually have a input color. And I'm just going to set the fragment color to just red for now. Okay. So let's see, we have the vertex coming in. We're converting that vertex to clip coordinates, setting a position, and we're coloring it red. So we should actually get red dots. So if I turn preview off here, or turn preview off for these points, come to my shader. Okay. Size is, say, 10. Always good to kind of double check what I'm doing. So a vertex coming in as a vec3, 1, 2, 3, 1, 2, 3. Index is coming in. Outputting a fragment color. Okay, well, let's back up. Drawing his points. I'm going to remove my vertex part, the index part. Just start this shader over again from scratch, actually. Make sure it's actually just working. I'm not getting points in at the moment. So what have I done? Let's go back to the points themselves. Pass them all the way to the vertex. So there's points there. And I guess this data is because it's coming in as strings. It's what's messing things up. Okay, there we go. So there's a bug in the GhGL shader, the GhGL component where it can't interpret strings correctly, it looks like. because the output of the panel, I probably could have just done this. I was expecting the panel output to be interpreted correctly too. Okay, so you can see there's little red dots on the screen. I'm gonna get rid of these other things. And now I'm gonna come back, I'm gonna add index. And I won't make that mistake for this one. I'll just pass in this guy back here. So I'm gonna go with my shader. In float index. So there are 30 vertices being passed in and 30 indices. And the 30 vertices, each of those vertices, there's 6 in a row that are being duplicated. And what I want to do is I want to expand those out based on their index into a quad. So in this case, what I'll do is I'm going to, I'll leave the color part here. I'll add the logic to expand out to a quad right here. And let's see, what do I want to do? I've got an index coming in as a float. In general, I like to pass floats in instead of integers, just because, at least on this computer, the driver is just flaky enough that it doesn't work all the time passing in integers. So inside the actual the GLSL code for the vertex shader, I'm going to convert that integer into convert that float into an integer. So I'll start with this first. I'll say which corner, convert the index into an integer here. And we're going to start with, say, if, do I still have those text dots there? I don't. Here. So we'll say if which corner equals 0, or which corner equals, let's see, do I want to do equals 1? Then I'm going to take the dot, the point, and I'm going to, let's say the point's right in the middle of this here, and I'm going to expand it by changing its x coordinate. So we'll say, let's say we have to, let's start with an actual vector here. So we're going to do vec 3 corner, not vec 4, vec 3 corner equals vertex. And then if you have 0 or 1, oh no, 0 or 3, let's say, we want to take that corner and we want to take x component and we want to subtract a little bit from it. So we're going to say minus minus 4. And we'll turn these into variables later on. Actually, I'll just build that in right now. Float width equals 8. And then we'll say float, or not float, width times 0.5. So half the width. We're going to change out in the x direction here. And to get live feedback, I'm going to just have corner here so we can start seeing the dots update. Just hit F5 to make sure. Now we got 2 dots. I don't know if that's really easy to see, but if I change this number from 8 to say 5, you can see on the screen here that those points are updating. So let's see, if it's 0 or 3, we want to subtract half the width. And if it's 1 or 2, we want to add half the width. And then the same goes for y. We want to say if it's 0 or 1, we want to subtract half the height. So we'll say the height. We'll just go with squares for now. Oh, and I should point out, I guess, as that's a good stopping point here, that I did upload these samples onto the GitHub repository. So let's see if I start a new window, GhGL, source, tests. There's a billboard 1 and a billboard 2, and that's what I'm actually recreating right now, are these two definitions. So if you just want to see how they work, they're right there. Okay. 0 or 3, we're going to change to x. 1 or 2, we also change to x. Let's do the same thing for y. So 0 or 1, we want to take the y, and we're going to subtract half the height. And if it's 2 or 3, we take the y, and we're going to increase the height. Okay, so now it's not super obvious, but you should start seeing, let's see if I enabled this guy preview. Start moving this point, you'll see that I'm actually drawing a quad for every point. I've mapped those points out, and so for each point going in, I've got the same point going into the shader a whole bunch of times, but I'm keying off of the different indices being passed in to figure out how to move that point around on the screen. And how that helps is actually because sooner or later, well, right now, we're going to want to change this from points to triangles. And now we've actually, because of the order of how we've drawn things, we're getting filled triangles on the screen. So I'm going to hide all this. Okay. And might as well, while we're at it, I'm going to add some variables to specify the size. So just going to stick with, let's see, I'll stick a width input and a height. And I'll hook those up to some sliders. So some big range, and I'll just make them always square, but they could be independent. You go into the shader now, and instead of declaring these width and heights, fixing them right inside of the shader code for the vertex shader, I'm going to declare that they were coming in from the component. So I'll have a uniform float width and a height. And come down here, and I'll just delete these two. And I'll say okay, and I should hit F5. And now I can actually just change the size of these quads. Now, the quads themselves are still in world coordinates, so we want to change those quads to be facing the camera all the time. And by doing that, that way we'll actually, when you're looking at billboards are always facing you. So to do that, we actually have some built-in functionality for a uniform to say, add a uniform of convert the world coordinate to a camera coordinate. And so this corner now, once we've actually figured out how to expand the corner out, we want to say, instead of being in the world coordinates for the vertex, I'm going to say the corner is actually move this over here so we can watch. So here's where it starts. If we do world to camera times this vertex out of vec3 of vec4. We always need vec4 is for when multiplying with 4x4 matrices. And then down here, since corner is now already a vec 4, probably just have to do this. Oh, and we should declare corner as a vec 3, it's not a vec 4. And what did I do wrong? Camera. A little tougher one today. World clip. Start with the vec 4 of vertex 1, 0. Let's make sure we're getting the points, which we already had. 3 to the corner. Okay. Position vertex color. Nice thing about GhGL is that you can kind of see when you're making mistakes right on the screen while you're working. So world camera times the corner. Shader constructor. GL position is the corner. We'll get there. I am missing something really obvious here. Let's see. Here's the problem. The corner's already in camera coordinates, so we want to actually convert the resulting GL position to clip coordinates, but we don't want to start with a world to clip transformation. We want to go with a camera to clip transformation. So that's going to be edit, insert uniform, camera to clip, and fingers crossed. Yes, there we go. Okay, that makes sense. So now these quads you can see are always aligned to the screen no matter what. So come back here, clean this up a little bit. Okay, and now we want to actually texture these quads. And so in order to do that, we need texture coordinates. So instead of outputting just a vertex color, we want to output a texture coordinate. So something like that. And in each corner, then we're going to have different texture coordinates. Let's see, we'll start with declaring one. So we're going to say texture coordinate. 0, 1. And then let's see. So when we have, can I show this stuff? So let's see if I go back to this, turn preview off, and I show, not show. We can say that we want the X part of the texture coordinate to start 0 along this line here, and 1 to be over here. And then the Y part depends on the orientation of the image that we're going to end up. It's going to be either 0 here or 0 here, and then 1 being the other end. So for this, we know that if we have 0 or 3, that's going to be 0 for the texture coordinates X portion. So dot X equals 0 in this case. And when it's 1 or 2, we know X is going to be 1. And then the same thing for working with the Y. We know that, well, let's just see. We'll just come here, say Y is 0 in this case, and 1 in this case. Okay, come back here. I'm gonna hide everything and turn preview back on for the shader so you can see the quads. And come to the fragment shader, and now we know that we had an output of a texture coordinate, so we want to have an input also of texture coordinate. The easiest way to do that is to come back here, copy this item, and in the input area, say in texture coordinate. And then we've still got red coming in for vertex color, but why don't we just vary it by the texture coordinate so we can see what's coming in. Back for texture dot X, texture Y. Comment this out, and now we can see that here we have 0, 0 for texture coordinates. X and Y are going to be 0, 0. Here is 0 for Y because it's just red, and 1 for X, and then you can kind of see the different items going on here. So we don't need this vertex color being passed in anymore, so we might as well just delete that just to keep things simple. And for the output here, we don't need to output a vertex color. So down here, get rid of that. Okay, we're in the fragment shader, and we want to get an image to come in, and then we're going to want to use those texture coordinates to draw the image, right? So click OK. So we're going to want to come over here, and we're going to say picture. Can be any, your variables can be any name you want. And there's several different ways to get images. I showed in another video. In this case, I'll just, sorry, that wasn't clear. Just use an image source, image resource. Set it to some picture that you have. Pass it into the shader. And now in the fragment shader is where I need to use this input picture. So I'm going to say, uniform sampler 2D picture. And I'm going to say vec4 color equals using the texture function in OpenGL, given the picture, and a texture coordinate. And probably have close parentheses. And then fragment color now is going to just be that color. It'll probably be black because GhGL doesn't recognize, doesn't recognize that it needed to get this picture. So I just have to come back to the canvas probably and just hit F5. Yeah, and there now it knows that it needs it. And you'll see that the image is actually upside down because of how I picked my Y coordinates for my texture coordinates. So that's easy enough. We'll just say here it's 1 and here it's 0, right? Okay, so that's cool, but they're always quads. So we're going to want to use alpha to actually be able to see different billboards or sprites behind each other. And so we're going to just need a PNG, some image with some alpha in it. So let's just start a new window. And I found a site. There's all sorts of image sites on the internet, we all know. And let's see, this one had some images with transparent backgrounds. So I'm going to just kind of try to stay here as little as possible because it can kind of creep me out. Say, would be a good one. Here, people. Let's do bones. Bones of the body. Grab a skeleton. Copy its image address. Come back here. Paste the URL in for that image and paste that in instead for the picture. And now we have images with alpha that you can see through. What's interesting is you'll get this effect, right? And what's happening is the alpha is actually being used in the Z buffer calculations and blocking out other images behind. And you can kind of see that if you go into the fragment shader and say, instead of just using purely the color from the image itself, let's just let's change that the alpha to 0.5 or something like that. And so now you can see here's the actual billboards that are being drawn, and this is how they're blocking each other. So as you spin around, sometimes they just completely block each other. And an easy fix for that is we can just say, you know, especially for images like this, if the alpha of the color is below some threshold, we're just going to throw the pixel away completely. Let's say 0.1. Just discard that pixel completely. And there we go. And so now, by discarding the pixel, it's not actually filling up the Z buffer and blocking out other pixels behind. Pretty cool. And so that, you know, you could use this and you could have, I would imagine you could have thousands and thousands of billboards and they would still run at pretty high speed levels here. Something else I'm noticing is that the placement of this skeleton is right in the center of the image. And for some billboards, probably especially for people, you're going to want to place the center right at the base. So the way to fix that is to come back here to the shader. And instead of, let's see, instead of changing the Y to expand out from the center, we're going to say for 0 and 1, we're not going to change the Y at all. It's still going to be 0. And for 2 and 3, we can probably just just use that corner, right? And so now by doing that, I've just basically, show in Rhino, I basically just preview off, delete this guy. I've just changed the point that you use from expanding quad out from this very center point to now just expanding this guy out from here, because I've gone up the entire distance. I guess we're upside down here. Here we go. I've gone up the entire height instead of the height over 2, which is done when you're here. Okay, so that's how you would actually just draw billboards with vertex shaders and fragment shaders. Now I'm going to go into a simplified approach to this, all of this with geometry shaders. Just wondering if anyone had any questions at this point. No? Okay. So there's a lot of work here. There's a lot of duplicating and creating indices that you need to key off of to work in the vertex shader. Another approach is what we can do is take all this logic that's here in the vertex shader and move it into the geometry shader. And in the geometry shader, we can create new data to work with based on your input from the vertex shader. So in that case, what we can do is, let me see if I've got some notes here. Yeah, so in that case, I'm gonna just save the document at this point. I'll just save this as billboard with vertex shader. And I'll make another copy. Geometry shader, let's say, billboard with geometry shader. And in this case, let's start up another shader. Do I need you to start one? Not really. Come over here. So we're gonna, in this case, we're gonna feed in vertices, but not feed in indices. And we're not gonna do all this vertex duplication. So in the geometry shader, we're gonna do this. We're gonna say first add this little tag at the top. This little tag of hash version 330 just basically tells OpenGL what version of GLSL it should compile the following code to. 330 is what we typically use. So for a geometry shader, we need to define what's coming into the geometry shader. So we're going to feed points in. And what's coming out of the geometry shader is going to be a triangle strip. And we also have to tell the geometry shader how many vertices at max we're going to actually output. In this case, we're just making quads. I think you can have quite a few. I've experimented with up to 64. We sometimes use geometry shaders for drawing curves and whatnot based on just a simple Bezier. But in this case, we really only need 4 vertices. And let's see, so from the vertex shader, let me just copy this, go over to the geometry shader, paste it, and we're gonna need world camera, camera clip. We definitely don't need world clip. We didn't before. We're gonna output a texture coordinate, we know that. And we're gonna go through a lot of the same gyrations as we went before. Now in the vertex shader portion, all we're doing is taking a vertex and passing it down to the geometry shader. Which means basically all this vertex shader needs to be is just outputting a position. We don't even need to transform this vertex, and we don't actually want to in this case. So we're just going to pass the vertex itself in world coordinates down to the geometry shader. We don't need the index either. So this is our vertex shader is now this. We get a bunch of vertices in, and we pass them down as just a position. That data gets sent to the geometry shader, and the geometry shader is going to start making vertices. Now in the geometry shader itself, the trick is we're going to start. Let's see. So we're going to start here and change. We can get rid of index. We don't need that anymore. Width and height picture we're still going to need. The draw mode is now going to be points, because we're just starting here with just points, and the geometry shader is just getting points in, and the geometry shader is actually doing the work of converting points into triangles. So let's see, how do I have that code set up? So we know that the point coming in is, this is what the point comes in like. It looks like this. Vec4 input from vertex shader equals, and there's a special GL in, which is an array, and it's got a GL position. And then that's still a world coordinate point. And so we're going to want to take that and convert that into a camera coordinate point. So we'll call that, let's see, in this case, I call it point equals world camera times input. Well, I wrote this really long, so I'll just copy and paste it. And let's see. So what a geometry shader does is it's going to emit more points. So we're going to start here. We've got an output of a texture coordinate, just like we did before. So we're going to start with a texture coordinate and define it. Zero. And we're going to say we want to make 4 output points, because we're going to create a triangle strip. That's a good way to actually get this output to be in triangle forms. So we want to take this this point, and we want to expand it out just like we did before. So we'll say vec4 corner equals point, corner dot x. Let's see, its x is going to be, we're still starting at the center, so we're going to take the width, subtract the width over 2. Corner x minus equals width times 0.5. We want to take the y coordinate and for the first point, and we're going to also subtract half the height. Okay, and then let's see, so the corner, this is in camera coordinates. Corner's width now, corner's position is shifted over by half the width and shifted down by half the height. And we want to say that the position that we're going to output is in clipping coordinates. So we're going to have camera to clip, and it's going to be times this corner location. Is that correct? Yes. And in a geometry shader, it's got this special function called emit vertex, which means that the texture coordinate at this point in time, the position at this point in time, get converted out to the fragment shader as another vertex. And we're gonna do this 4 times. I can delete the following code that I copied and pasted over. So we're gonna start with corner as the point, corner as the point, and corner as the point. We're gonna emit 4 vertices, and then you have to, at the end of a geometry shader, you have to also say end primitive. And that's just telling OpenGL or GLSL that we're done with creating this triangle strip. Texture coordinate undeclared. Oh, that's right, because I used that. Okay, so now, let's see, the second point, we're going to want to add half the width, and the Y is going to be the same spot. Third point, we're going to want to come back and add half the height. And on the fourth point, we want to add half the width and add half the height. Come to the fragment shader. And I would say probably the best thing to do here for now is just make sure that we're getting the color, the positions to come out correct. Color equals vec4. So, okay, cool, actually worked. So the geometry shader is outputting, now it's outputting 4 points, and it's doing this as a triangle strip. So it's actually starting in this corner as the first emit vertex, going to this corner as a second emit vertex, going to this corner as a third emit vertex, and this corner as a fourth emit vertex. And that just gets packed into a triangle strip and then passed down the fragment shader. The thing is that a single texture coordinate was being passed down at all these vertices, and in that corner, that skeleton image was just completely alpha, which is why you didn't see anything. So we can change that. Come to here, we know that we start with the first corner and we say that's, let's say that's 0, 0. Second corner, we went over in the X, so it's gonna be 1, 0. Third corner is coming back to 0, but up to 1 for Y, and then fourth corner is 1, 1. That also gets passed down to fragment shader, and we, with a little luck, this should give us upside down billboards, which is pretty common. You just come back and just flip your texture coordinates. There we go. And that's how you actually get geometry shaders to do your billboards. And we use this same technique for drawing points inside of Rhino. So you know, even without having to do an entire billboard of this size, because it can be any size, right? Our points now can actually be drawn this way too. All right. Well, I think that's it for today. Hope that made some sense.
Yeah. Thanks very much.
Yeah, it's a lot to cover. So thanks again, guys.
Yeah.
All right. Have a
Thanks.
good week.
Thank you.
All right.
Bye.